This instructional video is for textbook pages 125 and 126. We want to know who cycled faster. The table shows the total miles Sam traveled over time. The graph shows the same relationship for Bobby. Who cycled faster? So find the unit rate or the constant of proportionality for Sam. For Sam's table, we would find our pattern. 2, 3, 4, 5 is a pattern of positive 1. 20, 30, 40, and 50 is a pattern of positive 10. We set up our fraction y over x, so 10 over 1, and 10 divided by 1 is 10, or 10 miles per hour. And so again, that would be for Sam. Now, for Bobby in the graph, we would plot our points that we can read clearly. So it would be 18 and 2, 36 and 4, 54 and 6, 72 and 8. And we would make our pattern. 0 to 18 would be 18 points, and then 2 sideways. 18 to 36 would be 18 points and 2 sideways. 36 to 54 is 18 points and 2 sideways. And the same pattern for 54 to 72 is 18 points and 2 sideways. So again, if we were referencing even just the beginning points, going from 0, 0 to 18 and 2, we could use our pattern, again, y over x, represented as a graph as rise over run. 18 divided by 2 is a value of 9, or 9 miles per hour for Bobby. And so Sam went 10, Bobby went 9, Sam cycled faster. The equation y equals 15x can be used to determine the amount of money Y, Paulie's Pizzeria, makes by selling X number of pizzas. The graph shows the money Leo's Pizzeria takes in for different numbers of pizzas sold. Which pizzeria makes more money per pizza? So in our equation, y equals kx, the letter k stands for our rate of change. And so in the equation, y equals 15x, the number 15 is what represents Paulie's Pizzeria, $15 per pizza. For Leo's Pizza, again, we would graph the points we can read clearly, 0, 24, 2, 48, 4, 72, 6, and 96, 8, and find our pattern. 0 to 24 is $24, and that would be for 2 pizzas. Or it would be $48, so again, that's going up $24 for 2 pizzas. 48 to 72 is $24 for 2 more pizzas. And 72 to 96 is $24 for 2 more pizzas. We set up our fraction y over x. In the graph, it's called rise over run. $24 divided by 2 pizza equals $12 per pizza. And so Paulie's Pizzeria takes in more money. It costs more at Paulie's. Here's the amount of savings over time in Eliana's account. Lana, meanwhile, puts $50 each week into her savings account. If they both begin with $0, who is saving at a greater rate? So the word problem clearly tells us that Lana is putting in $50 per week, but we do need to solve for Eliana's graph. So for Eliana's graph, we plot our points, 0, 94 and 2, 188 and 4, 282 and 6, and 376 and 8. Finding our pattern, 0 to 94 would be $94 for 2 weeks. 94 to 188 is also $94 for 2 weeks. 188 to 282 is $94 for 2 weeks. And the last pattern, 282 to 376, is $94 for 2 weeks. So that pattern of y over x, rise over run for the graph, is going to be the $94 divided by the 2 weeks time. 94 divided by 2 is going to give us a value of $47 per week. And so the question was asking who is saving at the greater rate. Lana is saving more. Manuel and Petra are collecting sponsors for a walkathon. The equation y equals 20x represents the amount of money Beth raises for walking x miles. The table shows the relationship between the number of miles Manuel walks and the amount of money he will raise. Petra will earn $15 for each mile that she walks. In order to compare the proportional relationships, what quantities should you use to find the unit rate? So we want to find the amount of money raised divided by the miles walked. So that way we can figure out how much money it is per mile. That's what we want to find, per mile. So we're going to go ahead and compare them. For Beth, we have the equation y equals 20x, and we are referencing our equation y equals kx, where k is our rate of change. So in our equation, y equals 20x, the 20 is representative of Beth's amount, $20 per mile. The table is representative of Manuel. To solve the table, we find our pattern. 3, 5, 7, and 9 is a pattern of 2 miles. 45, 75, 105, and 135 is a value of $30. Setting up the fraction y over x, 30 divided by 2 is a value of 15. So Manuel gets $15 per mile. And the final value, it tells us Petra. Petra earns $15 per mile. And so we can answer the question, compare the amounts of money. Well, Beth raises the most. And Manuel and Petra raise the same amount. Compares the heights of 2 plants to see which plant grows more per day. The table shows the height of plant 1 in centimeters over 5 days. The graph shows the height of plant 2 in centimeters over 10 days. Winston says that since plant 1 grows 6 centimeters per day and plant 2 grows 4 centimeters per day, plant 1 grows more. Do we agree with Winston? Explain. So for plant 1, we find our pattern. 2, 3, 4, 5 is a pattern of 1. 6, 9, 12, and 15 is a pattern of 3. Set up as a fraction y over x, 3 divided by 1 is 3. So plant 1 goes 3 inches per day. So already Winston is wrong. Plant 1 does not grow 6 centimeters per day. It grows 3 centimeters per day. Looking at graph 2 for the plant, we have 0, 0, 4, 2, 8, 4, 12, 6, and 16, 8 for our points. Finding our pattern, we go 0 to 4 is 4 centimeters over 2 days. 4 to 8 is 4 centimeters over 2 days. 8 to 12 is 4 centimeters over 2 days. 12 to 16 is 4 centimeters over 2 days. Our fraction y over x, rise over run, would be 4 divided by 2. And 4 divided by 2 is 2 centimeters. So plant 2 grows 2 centimeters per day, not 4. So no, we do not agree with Winston. Even though technically he was correct, plant 1 grows more. Plant 1 is growing 3 and plant 2 is growing 2. So plant 1 does grow more. His answers were incorrect. Winston simply looked at the first initial value given. So he saw 6 centimeters and that was how much it grew. Same thing for the second problem. Our first point was at 4, so it grew 4 inches. He only looked at the first point, not the pattern in the table or graph. Alexa and Clara want to know who types the fastest. The equation y equals 39x models the rate at which Ashton can type, where y is the number of words typed and x is the time in minutes. The table shows the relationship between words typed and minutes for Alexa, and the graph shows the same relationship for Clara. Who types the fastest? So with our three values, we have Ashton, which is our equation, y equals 39x. In the equation y equals kx, k is the rate of change. And so for Ashton, it would be 39 words per minute. For Alexa, we're going to solve the table. So finding our pattern, 2, 3, 4, 5 is a pattern of 1. 78 to 117 to 156 and then to 195 is going to be a value of 39 each time. Setting up the fraction y over x, 39 divided by 1 is 39. So Alexa is 39 words per minute also. For Clara, we graph our points, 0, 278, 4, 156, 6, 234, and 8, 312. To go from 0 to 78, we would do that in 2 minutes. 78 to 156 is also 78 words in 2 minutes. 156 to 234 is 78 words in 2 minutes. And 234 to 312 is 78 words in 2 minutes. Setting up our fraction y over x, which is rise over run for the graph, we set it up as 78 divided by 2, which gives us a value of 39. So Clara is also 39 words per minute. And so the question is, who types the fastest? They all type 39 words per minute.